Welcome to DV Workshop channel. In this session we will learn what is algorithm. Algorithm is a step-by-step instruction to solve some problem. For example, we have been provided a list of these numbers and these numbers are in ascending order and problem is to search 9 in this list. So how we do that? We need to have some kind of step-by-step instructions to search this value. One may say that just check each and every number sequentially and if 9 is found, that's okay. But the problem with that algorithm is that it is very time consuming. If you have hundreds of numbers and if you keep on checking each and every number sequentially, it will take too much of time. Let's consider this example. This is a list of few numbers and these numbers are sorted in ascending order. So algorithm tells here that just find a middle element, that is 8 here, and compare it with the element which needs to be searched. For example, 9 needs to be searched, so we have to compare 9 with the 8 and we have to see whether 9 is less than 8 or greater than 8. If it is less than 8, that's obvious that the number would lie in the left hand side of this list, or if the number is greater than the middle element, then it is obvious that number would be on the right hand side. For example, 8. 8 is less than 9, so that's obvious that 9 would be on the right hand side of this list. So it is just obvious that we could drop the left hand side of a list and we just consider on the right hand side because the item which we need to search is on the right hand side. So now list becomes 9, 10 and 15. Now again see the middle element. Here we have a 10. Now compare the 10 with the 9. Now we found that 9 is less than 10. So that's again obvious that now 9 would be on the left hand side of our list. Now we ignore the right hand side. Finally we found 9. This is called divide and conquer algorithm. Say this, divide and conquer, and we have to split the problem into the small problems that can be solved. Even if we found that this problem is difficult to solve, we keep on splitting it until we find a very small problem which can be solved. Or this can be used on a other way. For example, you have a small problem, you just solve that problem and you then merge it. First of all, you just take a problem and then you just split it into number of sub problems, and each sub problems is divided into again sub problems, and you keep on dividing it until you reach to the point where problem becomes very small and that is manageable and that is solvable. Now you solve that small pieces of a problem. Once you solve the small pieces of a problem, you keep on adding them and then you keep on adding the solved pieces to generate a final problem. So this technique is called divide and conquer technique. This is just to give you insights about what the algorithm is. Algorithm is just a step-by-step instructions to solve a problem. Now consider one more example. For example, you have a phone book. In that phone book you have a find a number of a person Nitin Manik. If you want to search Nitin Manik in a phone book so that you can find his phone number, how you do it? The step 1, you get the phone book. Step 2, you just open the phone book to the middle. Now you read the page. If you find the number, if you find the Nitin in the current page, that means your problem is solved. you got success. Otherwise, if Nitin is not in that page, now there are two chances. Either Nitin is on the left hand side of the book, or Nitin is on the right hand side of the book. Now, if the Nitin is in earlier book, how you know that Nitin is on the earlier in the book? Because phone book is alphabetically sorted. So you know the page you have opened, the middle page you have opened, you know what alphabet is there on that page. If it is the alphabet is less than n, that means Nitin would be on the right hand side. If it is greater than n, then Nitin would be on the left hand side. Now consider that Nitin is earlier in the book. Now you again consider the left half of the book as a complete book, and you repeat the same process again. You again split and you again decide. You again go back to line number 3 and repeat the same process again. Consider a situation where Nitin was not in the earlier in the book. Then it would be obviously it would be on the later in the book. It would be on the right hand side of the middle page that you have opened. Now again your right hand side is a sub problem, and you have to solve that problem in the same way as you solve the main problem. Again you go back to the line number 3. In this way you keep on splitting the pages and divide the book half and half in each and every step. So either you find the phone number, either you find the Nitin, or if you just run out of the pages and you don't find and you don't have any more pages, then what you do? Then you come here. You will reach here only. There is no left half of the book and there is no right half of the book, and Nitin is not found. This means Nitin was not there in the book. So you have to print this message that phone number is not present on searching until G, because in the phone book you would have only people with these names, starting name either A, B to G, right? So for example, if you're searching for person with name M, how you do it? You just split the problem from half, and then you came to know that okay, in this half your the person you want to search is on that half. You again split it and try to see if the person you are searching is on the right half. You keep on splitting it until you reach to the person which you want to search. Let's see this example. Consider these are the numbers and we have to arrange them in ascending order. We split the problem in 4 pieces, then again piece is split into again 2 pieces, and now we have a manageable problem. And now we can sort. We take two numbers and we know we arrange them in sort ascending order. We can sort them. Now we sort two numbers, and again now we can combine them. So this is just breaking the big problems into the small problems and then combining and solve those small problems and keep on adding the sub problems, sub solutions, and then build a final big solution. This is about algorithm ascending order, arranging of the numbers in ascending order, right? So this is called Mergesort. Let's take an example. For example, consider this is a phone book, for example, and if you have a 0 pages in a book and you have this algorithm, for example, this is the name of algorithm. If your phone book has a 0 pages, the number of steps you take to solve is 0, obviously. If you have a 1 page in a phone book, and number of the steps you take to find a number, because phone book has only 1 page, you only take one step to turn that page and see if person is there or not. If the phone book has 7 pages, you could have to turn all the 7 pages, right? This is a very simple algorithm that you just keep on sequentially searching from page 1 to the last page, and consider a situation that the number you are searching is on the last page. So this is one of the algorithm. The problem with this algorithm is the number of pages in a book, you have to turn that many pages. So this is not a good algorithm. This is a very bad algorithm, right? Now you got some other kind of a algorithm where you have a half number of steps. Divide half. This is divide and conquer. Whatever we have discussed before in this session is this algorithm. This is a very good way of searching a number. And for example, if you have a book with 90,000 pages, you could solve the problem in 17 steps. Quite interesting, right? There could be some other kind of algorithm that take more than whatever is the number of pages. For example, there might be some other kind of the problems that is not just searching a phone number in a book. There could be some very different kind of a problems. For example, Mergesort we have discussed. It is not about that number of steps it would take, that how many numbers you have to rearrange. For example, even if you have to rearrange the sorting the 10 numbers, it does not mean that it could take only maximum of 10 steps. It may take 20, it may take 100 steps, right? So this is some algorithm that is taking 4n. For example, if number of element in the problem statement is 7, it is taking 4 times of that number. See the formula here, how we write a Excel formula for this. See, equal to a5 into 4. See here, for if we want to get this value, we just take equal to is for formula, and we take a value from a5 and into 4, because the algorithm we have designed is taking is a complexity of 4 into n. That means if you have a 7 pages in a book and the activity you want to do is taking 4 times more cost than the number of pages. For example, if you have to arrange the 7 numbers and you need to 28 steps to arrange them, or maybe whatever the problem is. So there could be some other kind of a problems that could take 10 times steps. There may be some other problem that take n factorial number of steps. There could be a problem that take 2 raised to power n. That means 2 raised to power 7 steps. So let's plot a graph for it. We already know how to plot a graph for such data. So we just select all the data, we just click on insert, we click on chart, and now you see that some algorithm is just flattened. So the curve is flattened. That means once we increase the number of pages in a book, the number of steps we need to do does not increase dramatically. So these are a good algorithm. If you find the green line, it is a good algorithm. If you see these slanted lines, these are bad algorithm. So we have plotted a graph based on these values. So this picture I have taken from a book, and this is telling us that what kind of algorithm is good and what kind of algorithm is bad. For example, if you see the baseline, the green line, any algorithm that take log n number of steps is awesome, is an excellent algorithm. If somebody is of order n, it is just a good algorithm. You may say that it's a fair algorithm. Otherwise, if we take n log n, it is a bad algorithm. N log n means the number of steps it would take. Here it is log to the base 2. If it is taking order of n square, that means if you have n number of elements and the number of comparison you have to do is n square, that means you have a 5 elements and the number of comparison you have to do is a 5 square, that is 25 times you have to you have to do the 25 steps to solve the problem of 5 elements. That's too bad. If you have to do the 2 raised to power 5, that's again worse. That is horrible. So this was all about the algorithm. Algorithm is just, again, algorithm is a step by step in instructions to solve a problem. It is just pseudocode English like instructions to solve a problem.